There we go.
Right. Okay, so we're welcome to the first sync. We wanted to chat about Cells 1.0 proposal, and in particular the global uniqueness requirements for sequence values, and how we think that in production, on average, a few times a year, that global uniqueness requirement is going to be violated. I'm certain that there are other scenarios that I have not thought through, but I'm quite confident that at least the scenarios that are covered in the issue are going to cause collisions where the same sequence value can be reissued more than once. So I opened an issue day or two ago, yesterday, I think. And I have not read any of the comments yet because I've been sidetracked on other things. What's the most useful format for this discussion? Should I talk through the problem first, or do you want to start talking about solution space? Maybe I'll start with just a very brief recap of the problem for folks.
Maybe a short one. Yeah.
Okay, so in Postgres, sequences are, despite the name, they're not guaranteed to provide sequential values. They are guaranteed to provide unique values within the context of that Postgres database, that Postgres instance. So if we create a sequence and open a transaction and call next val on sequence foo, we'll get whatever a guaranteed never before issued value would be. So if it's a brand new sequence, the value would be 1, and the next call to that function would return 2, regardless of whether that's in the same transaction or another transaction. So that's one kind of subtle point, is that sequences are not constrained to a transaction. You can have 2 concurrent transactions, and they can safely atomically call next val and get a guaranteed unique value. The way that
an aborted transaction is not going to roll back the sequence and reissue.
Exactly.
Yeah,
exactly right. So the way that works under the hood is Postgres guarantees durability for events, including sequence value consumption, by generating a write-ahead log record, a wall record, for that sequence having a value be consumed. And that is part of the replication stream that goes out from the primary database to its replicas. So now we're going to shift gears and talk about replication. When there are Postgres, as many databases do, Postgres supports a few different modes of replication. Everyone initially thinks, oh, of course I want synchronous replication. I want to guarantee that transactions and sequence values in our case are guaranteed to be propagated from the primary to the replica, so that if I have a failover, there won't be any data loss. And that's not actually what we that's not what we, and that's not what most systems are actually designed to do. We use asynchronous replication, so we have near real-time propagation of committed transactions and consumed sequence values. So there will be, at any instant in time, for a high throughput system like the production environment, there will be a lag, often measured in milliseconds, but it's a non-zero amount of time that lags for each replica to consume data from the primary. And that includes sequence value consumption, so as well as committed transactions. So whenever there is a failover event, or more generally, whenever there is an event, we're talking about databases here. So whenever there is a database failover event where the old primary gets demoted and one of the freshest surviving replica gets promoted to the primary, there will be some non-zero amount of wall records that existed on the old primary, on the old primary's timeline specifically, that are not included in the new primary's timeline. So it looks like your classic kind of fork shape, where this is the old timeline, and at some point prior to the tip of it, we fork off and start a new timeline on the new primary. And this region is what we're talking about losing, and that will include consumed sequence values. The consequence of that is on the new timeline, we will issue the same sequence values again that were already issued, and they are very likely to be consumed by something else. So for example, if the 10 milliseconds before, I'm making this up, if 10 milliseconds before a failover event begins, none of the replicas have consumed a wall record associated with having consumed sequence value 1000 for some table. Let's just say the projects table, just to pick one. So there's a new record in the projects table that has a brand new primary key value pulled from this sequence, and it's associated with some organization. After the failover, that sequence value will be issued for some other completely unrelated project, and it may be consumed by one of the secondary cells. It may be consumed by the primary cell. There's no deterministic mapping of who consumed the value originally versus who consumed it afterwards. And this is the fundamental nature of our concern, is that we violate that expectation that a sequence value is guaranteed to be unique. That's true, except in this scenario where we have effectively a timeline split, and the non-replicated portion of the old timeline includes that defines our range of effectively of data loss, which includes sequence values, and those sequence values are the ones that will be that represent our collision cases, where they're guaranteed to not be unique, which is the opposite of what we want. Okay, so that's the problem, and I kind of saw two outcomes of this.
But I have a question, like, how big can be like a timeline speed in terms of the when was like the change class committed versus what we are recovering from?
That's a great question. So
what you expect, basically?
Yeah, so it very, very much depends on the circumstances. When we do okay, actually, I do want to take a couple minutes to dig into this. So normally I would say I would expect that to be measured in tens of milliseconds under healthy conditions. But we're not guaranteed to be under healthy conditions. And crucially, we've talked about, so I know that there are a lot of goals associated with the cells project. In my mind, only one of those goals is super, super duper critical, and that is dealing with the fact that our database cannot vertically scale much more than it already is. And there are a few reasons it can't. In other words, there are a few resources that we're running out of and can't add more of. And like usually when we think about, how much capacity do we have left, we're talking about machine resources, CPU, memory, disk IO, network IO. But that's not all. That's not all that we're running out of. One of the critical things that we are kind of perilously getting close to is replication throughput. I want to take a moment to I did a detailed write-up on this, and I'll look for it and add a link later. But I'll just verbally describe this is the same replication that we were just talking about, where a primary generates wall records, and those are shipped to, those wall records are propagated to secondaries, to replicas, and consumed and applied. So there are three processes that implement this pipeline. There's a wall sender on the primary side, a wall receiver on the replicas side, which is a separate process whose only job is to read data off of a TCP socket and write it to local files in a sequential manner. And the third is a process for applying that wall data that has been written by the wall receiver. So that middle process in that chain, the wall receiver, that is the bottleneck that I'm concerned about. That is effectively, for practical purposes, it is a single-threaded process. It's not truly completely single-threaded, but for practical purposes, it's very much like Redis in that there is one thread that does virtually all of the work. It is not bound. It's not entirely bound by CPU and not entirely bound by disk IO, but it's in terms of total wall clock time that it spends either on CPU or waiting on disk IO. We're last time I looked, I think during peak workload, we were at about 80%. We cannot improve the bandwidth for this process. It spends a large proportion of its non-idle wall clock time waiting on disk IO, because unfortunately it calls fsync on these wall records that it's writing, on the wall files that it's writing up to disk. And so it's sensitive to physical write latency on the disk. This is a little bit more detail than I meant to go into. Let me bring it back up a level.
Yeah,
If
we're about halfway through. So
oh wow,
I think,
okay.
Yeah, if we want to talk about some solutions as well, let's try and.
I'm kind of asking about the time, because it's not a new problem, and it's like also pre-existing problem, because we attach a bunch of the data to the database resources based on ID, be it private ID, be it like object storage resource.
Yeah.
So
I mean,
technically, in case of the disaster
it
recovery,
exists.
when you roll back by 6 hours, you kind of have already an overlapping IDs problem in the two.
Yep.
So I'm kind of really looking like for the number that we are trying to solve, which is like, because I think like in case of the disaster recovery, the procedure is gonna be different than in case of the regular operation. Because from what you are telling, failover is something that happens rather frequently, and we should have a solution just for the failover when it happens. But disaster recovery, I think like this terrible case where we have to roll back by snapshot for a few hours is something that should not really ever happen, and it's very likely a different solution for that problem. So that's why I'm kind of asking for what problem we are optimizing at the current moment.
Yeah, for what it's worth, I agree with you. I don't think we should attempt to solve the disaster recovery problem. I think that is, honestly, I think that's an intractably complex problem that we're not likely to actually solve legitimately. We have no way to reconcile the many data stores that need to be realigned in a disaster scenario. So I think in that unlikely scenario, we're going to have inconsistencies, and we'll have to deal with them after the facts, rather than return to some consistent point in time across all data stores. That said, I'm only focused on the failover case right now, and I want to emphasize again that there very well may be additional cases that I haven't thought of, but this one I'm confident is a deal breaker. Yeah, and
cool.
and
thank you for clarifying that, because I think like it also gives us a better perspective on what time of the duration we are looking at in terms of the range.
I think it's milliseconds. I think it's probably tens to hundreds of milliseconds, but we have definitely seen. So I was talking about replication partly because that's one of the resources that we're running out of, and we already had a production incident where the change that was introduced, the application change that was introduced, increased the amount of data that we were trying to push over the replication pipe to the point where it did saturate, and that is that was catastrophic, because it meant that the replicas couldn't keep up with the replication workload. All of the Rails instances decided, oh, the replicas are too stale to use. I have to use the primary for all of my workload. This crushed the primary, and we had the normal cascade of slowness and errors that resulted from the primary being overwhelmed by workload.
Right. And if there's then a failover in that situation, then we're at risk of losing having quite a bit of a larger delta. Exactly.
And I'm actually kind of surprised that didn't happen in the incident I'm thinking of. I think we were just lucky during that one. So this is a serious problem, and we shouldn't consider it to only be losing a few hundred milliseconds of replication data. Although I think the normal happy case where it's failovers are never happy, but in the kind of smaller benign case, we should still expect to lose quite a few sequence values, because we consume sequence values database wide at a rate of 1 per about half a millisecond during the, I think, the shallowest part of the day. And anyway, we will lose lose and reissue some sequence values during any of the failover events, because our replication lag is definitely more than 1 millisecond.
So I do think one of the things that you mentioned, Camille, which is that this issue already exists in our non-cells world, is an interesting one. And I guess we can sort of maybe, we don't need to do it synchronously in this call, but I think that's maybe also useful framing to explore further and look at what are the consequences of losing sequences in the status quo, and what are the consequences of that in a cell's world, and like what's the impact of that, right?
Yeah.
I'm gonna say that like any solution that's gonna allocate a sequence externally, it's gonna prevent the same sequence like used across different cells, but it's not gonna prevent the same sequence being used within a given cell if the failover happens. So the same idea gonna be reused because it's gonna happen anyway. So it's like a solution that really solves like a cross-cell referral integrity, but it doesn't solve the problem within a cell. So I think we have to just take it on the face value, honestly, that this can happen and require that any other externally attached resources, this is my comment, they do not use primary key value. They just use some other generated value that is random, it's stored, but it's not connected with just the database sequences. We use database sequence for the projects today, for the big store items, for a bunch of other stuff, which is actually, I feel like, at least in the case of the GitLab, it's actually like the problem, because you could probably end up in the failover, create a project at the correct moment and get access to the same repo.
Yeah.
So it's actually the problem.
That kind of thing happen. Yeah.
It's
definitely.
actually the problem within the cell on its own.
And
that we have
it's
to
not,
solve.
it's not only GitLab, right? It's also Redis, like anywhere where we're using IDs, we're affected.
Exactly. This is an anti-pattern that we've got scattered throughout.
But I agree. Given that is an existing issue, that's not something that's in scope for us to solve right now.
Right. I was mainly concerned about how this would manifest in the context of cells. So using, I kind of didn't want to get into the solution space deeply, because I think there are a few options, and I haven't personally I haven't finished thinking through the consequences of even the solutions that I have thought of. But I already know that those solutions have major drawbacks. There isn't an easy solution to this problem that's going to be cheap and effective, to the best of my knowledge. But we can talk through that. We can. I feel like this needs to be an async conversation. The exploring the solution space.
I think there's one aspect that I did want to kind of touch on,
Sure.
which is when we're talking about handing out IDs, we're usually going to be looking at ID ranges. So we have like our mothership cell, and the other cells are going to request ID ranges, and they're going to get enough for like quite a while, right? So within that range that they've gotten, there may be like internal failovers that result in reuse of IDs there. That's like a cell local problem.
Right.
But as if as long as we solve the non-reissuing of those ranges, then I think that should address the core of the issue. And I guess one of the things I wanted to ask is, if we're doing this with ranges, then the rate at which we request those is going to be very low, right? Like it's going to be
And
like,
I suspect that we're also not really worried about milliseconds, but more about minutes, because I don't think that we would request a new range right before we, like the next time we need an ID, we need to get the range. I think we would
right,
do
we
this.
do that ahead of time. So it's like,
Yeah.
oh, we've only got 1 million left. Let me go back and request another 10 million and replenish my my stash.
Yes, I think in my head, like first, like in 1.0, we would request that from the primary cell because it's easier. That's the idea currently, but we'll request and like replenish that probably daily to have at least 14 days of the runaway time, at least, I think. For the short time primary cell unavailability issue. So we would really request not for a few minutes, we would request for days or maybe even months in some cases where we have space. The amount of the IDs that we would request, it's depending on the size of the identifier. It's just, we have a lot of tables that are 32 bits. A lot of big tables like CIBs that consume significantly more, they are 64 bits. So we can actually allocate significantly more ahead of the time to actually request less frequently for those cases. So the problem, why is this solution, is just it takes a lot of effort to migrate all of the columns to be 64 bits, or even like UUID. But over time, like we're gonna slowly be migrating more and more tables to be 64 bits because we're gonna be using ranges. We are gonna be consuming IDs on much higher rate in a cluster. So we're gonna be consuming 32 bits much faster than we are doing that today. So it's gonna effectively accelerate the need to migrate those columns at some point. But somewhere in 1.5 or 2.0, the idea is like that we're just gonna have a global service that is gonna be issuing next range to a cell that it can use. So we don't have like a special dependency on the primary cell, or like the primary cell is no different to any other cell. That's really like the idea of progressing. And how it would be implemented from the perspective of the global service, where it would be stored to ensure this uniqueness, it's actually like we have to figure out what gives us these guarantees that Matt is telling about.
So with regard to issuing larger ranges, Camille already touched on this, but I was concerned about the rate at which we consume sequence values, particularly reserving ranges for presumably a non-trivial number of secondary cells will potentially consume the sequences faster. And I'm sorry, I'm not fully awake yet. It also wallpapers over the problem. Yes, I think that reduces the collision rate, or it reduces the probability of hitting a scenario where the range claim is part of the abandoned portion of the old timeline by making that a rarer event. I don't remember if I listed that in the initial write-up, but I did think about it, and my intention was to not mention that because I didn't want to make it seem like there was an easy way out of this problem, because this is just a manifestation, right?
Yeah, I agree. I don't think that's a viable option to just be like, oh, it's unlikely, right?
Yeah,
we want some stronger guarantees than that.
Exactly, yes. Exactly. But I do agree that that's an effective mitigation. It's a cheap, effective mitigation.
So
it also gives us time to validate. Like if we request a new range 2 weeks in advance, then we've
Yeah.
got time, 2 weeks time to ask the service in the beginning of the primary cell. We can ask the like, are you sure I can still have this claim? And then
Actually,
Sure.
actually, I would propose something different. You just request small range every day up to the limit that you expect to have, and you just you always have like, I guess like for the 40 days you have like a 40 ranges that you can use, and you just continuously request and validate them as you go. You just make it frequent operation. I mean frequent, let's say daily, instead of non-frequent, because the larger range you have, the more risky it is. But the smaller range you use, it's actually much easier for the system to adapt to the rate of the consuming the range, but it's much easier for system to confirm that this range is actually claimed, because you can do it on the daily basis or whatever rate you want it to be. So I'm kind of, we need to, I think, somehow balance how much we pre-allocate versus how quickly we confirm those stuff, or like what is like the minimum acceptance criteria. I'm actually worried about these 32-bit identifiers and to not consume too much, so we don't run out of the space on the current GitLab.com. Our system depends very heavily on monotonic sequences, that they are kind of ordered by time, which is not always true, but it's true in a lot of cases. So, but this is something that it's kind of worrying to me. So I think like there's gonna be a trickiness in finding the right balance between how much to ensure that it's not too much, but also how frequent to ensure that it's not too frequent, but not too rare process to do.
Yes.
Okay.
Some other.
We're at time, and there is a cells AMA that I think Steve and Camille will need to run to.
Yes. Sorry.
Next time we can talk about synchronous replication and semi-synchronous replication as some potential spaces we can explore.
Yeah.
Particularly for claiming ranges. Okay. Thanks all.
Okay. Thank you all.